Welcome to the session on data protection and compliance on Amazon S3. My name is Nitish Pandey. I'm a product manager with Amazon S3 and Glacier, and I'm joined today by Anusha, who is a principal engineer at Amazon S3. And before getting started on the features, I would like to share a couple of fun facts with you. Do you know Amazon S3 performs more than 100 million requests per second? Yeah, that's your get and put request. And we store more than 200 trillion objects in Amazon S3. That's almost 26,000 objects for every person on this planet, or 100 objects for every known galaxy in the universe. And I would like to thank you for trusting us with those objects. The protection of your data is our top priority. And in addition to all the work that we do behind the scenes to keep your data secure, we also give you a ton of capabilities that you can use to meet the security and compliance requirements of your applications. These features are available throughout the lifecycle of an object in S3, whether when you are uploading or downloading from S3 or for data stored with us. Today, first I'm going to talk about a new feature that we have launched last week to offer you additional checksum options during upload and download. And this will be followed by features that you can use for data protection and compliance on objects stored with us. So let's start with data integrity checks during upload and download. We have a number of customers who are migrating their entire on-prem data infrastructure or digital assets stored on other cloud to AWS. They are moving billions of objects, 100 plus petabytes of data, and want to verify that every single byte landing in AWS as a durability best practice. Currently, customers use MD5 checksums for performing these checks. However, customers asked us for additional checksum options that can help them meet their compliance and regulatory needs and to perform faster checks during data transfer. And we have heard you. And now we are super excited to announce the launch of new checksum options that you can use to bring your critical data from on-prem onto S3. For the first time in the cloud, you can now choose from 4 supported checksum algorithms for data integrity checking on your upload and download requests. And in addition, we have made enhancements to AWS SDK and S3 API that can accelerate integrity checking of your requests by up to 90%. Now, if you don't know what a checksum is, a simple way of thinking about it is that it's the digital fingerprint of an object, which can be used to track any change in data during transmission or at rest. How do we use checksums? It's simple. You calculate the checksum of the object at the source, then after the transmission, and compare the 2 checksums. If they match, then perfect. Your data, despite traveling at the speed of light, is still unchanged. If they don't match, it means the source object and the destination object are not the same. And S3 can use this information to only succeed the request when these checksums match. Now that you know about checksums, let's talk about the new integrity checking capabilities in Amazon S3. But first, let's talk about the new algorithms we are supporting. For the first time in the cloud, you can choose from 4 supported checksum algorithms. The algorithms are secure hash algorithms and cyclic redundancy checks. Now you can use a SHA-1, SHA-256, CRC32, or CRC32C checksum algorithm, depending on the compliance or performance requirements of your application. And in addition, you can select one of the 4 algorithms and provide a pre-calculated checksum value to validate the object and store it throughout the lifespan of the object in S3. We'll preserve the checksum value you provided during lifecycle transition, replication, moving to another storage class, or any other S3 operation. Even after 10 years, 15 years, or 100 years when you download the object, we'll use the exact same checksum value you provided at the time of upload to offer you end-to-end data integrity. We also talk to customers who are dealing with bigger and bigger objects. These customers are media houses who are storing ultra high definition videos using the best cameras available, space technology and geospatial companies translating Earth as a dataset by capturing and storing high resolution images of the planet, to research institutes storing and processing large genome datasets. These are few examples, but really this is something that we are seeing across industries. The objects are getting bigger and bigger, and as that has happened, integrity checking gets harder because, well, math. checksums take longer and longer to run. This means they become more expensive and time consuming. So we went back and tried to figure out how we could make integrity checking on big objects faster and more reliable for our customers. At the end of the day, if you want to speed up a process by an order of magnitude or so, you probably need to figure out how to parallelize it. And that's what we have done here. We are introducing two optimizations for integrity checking that together can accelerate your integrity checks by up to 90%. The first thing that we did was to enable you to pass in a checksum as a trailer instead of only as a header, which is what we do today. And now this is a bit subtle but has a huge impact. It means that you can calculate a checksum as you stream the bytes to S3 and then just tag it onto the end of the request. And the second thing that we did was to enable customers to break up large objects into parts and then to checksum those parts in parallel. We enable this both on upload and later on when you want to come back and check the integrity of the object at rest. This is a big deal too because it means that you don't have to sequentially process a huge object that could be terabytes in size. You can break it up and farm that work out to many cores, all working in parallel to check your object integrity. So that's what we have done. Let's dive a bit deeper into each one of these options. First, let me talk about trailing checksums. Today, to verify the integrity of your data, you first calculate the checksum of the object, and then you upload the object to S3. But these two things, the calculation of the checksum and the streaming of the bytes to S3, have to happen sequentially. This means that both operations take wall clock time, as well as their own processing power, which means more time and cost. But with trailing checksums, what you're doing is to calculate a checksum as you stream the data into S3. This saves you time as you're able to both verify and transmit your data in a single pass instead of as two sequential operations. To do that, you specify the checksum algorithm in the put header request, and the AWS SDK will automatically calculate the checksum and append it as a trailer to that request. This workflow is efficient and will save you time and resources, as you don't have to calculate the checksum on the client side separately before uploading the object. It also enables computing checksums on streaming uploads where storing the object to a disk as an intermediate step would not have been possible. So it is what that looks like in the S3 API. You can specify the XAMZ trailer header telling us that you are going to send XAMZ checksum SHA-256 value in the trailer, and then you upload the object, and the checksum value is followed by the object. Previously, all additional data you sent to S3 had to be in the header of the request or before the object data. Now let's talk about parallel checksum operations. Now when you upload a big object into S3, you are using S3's multi-part upload API to do that. Our new checksum options will continue to work with multi-part uploads with minimal changes. Just like with simple single-part objects, you can pass in a new checksum algorithm like SHA-256, and we will happily check the object with the algo that you specified. Now, just like we do with our MD5 checksums today, the whole object checksum will actually be a checksum of checksums. So how do we calculate this value? It's calculated by checksumming each of the individual parts checksum to provide a whole object checksum. This is useful, but to compute this value, I need the part sizes or boundaries to do a full object validation for any object just sitting in S3. This data is not easily accessible today. So to help you to completely parallelize checksum operations, we are launching a new API called getObjectAttributes, which will provide part-level metadata and checksums. When you call this API against an object in S3, it will give you checksum algorithm, checksum value, part-level checksum values, part boundaries, number of parts, all the information you need to go run integrity checks on a large object in parallel down to the part level. So it took us 86 minutes to calculate the SHA-256 checksum value of 1 terabyte object. With those same EC2 instance types, we were able to perform the integrity check and do that in less than 7 minutes. We believe that this is a game changer for our customers who need to run large integrity checks, and we are super excited that it's available to you. Now to summarize, You can now accelerate the integrity checking of your objects by up to 90%. You can choose from 4 supported algorithms. You can check the integrity of any object, whether encrypted, multi-part upload, or single-part objects. And finally, the enhancements to AWS SDK and S3 API will significantly improve the checksum efficiency. And now I'll hand it over to Anusha to talk about protection and compliance for data stored on S3.
Hello, I'm Anusha, a principal engineer on Amazon S3. So far, Nitish walked us through how you can get your business-critical data on S3 and verify the integrity using our new checksum options. Let's now talk about how you protect your data at rest on S3. When you store your data with S3, every object is redundantly stored with 11 nines of durability. What this means is that for every 10 million objects you store on S3, you can expect the loss of a single object every 10,000 years on average. Now, those are some pretty good odds for retaining your business-critical data. However, this does not protect your software from accidentally overwriting or even deleting these objects. So how can you protect against this behavior? A feature called versioning on S3 is an excellent answer to that question. Versioning is a powerful tool on S3 for data protection, and you can use it to preserve and retrieve every version of every object in your S3 bucket. After versioning is enabled for a bucket, if Amazon S3 receives multiple write requests for the same object, it stores all of those objects simultaneously. Let's look at an example. You have a versioned bucket and you upload a photo to it. Now, the first time you upload this key, S3 will add a unique version identifier to this object. Let's call it the first version. Now, if you overwrite this photo, S3 will now add a second version of the photo, but also notice that it stores the previous version along with it. If you did not intend to do this right, you can go back and retain the earlier version. In addition to protecting against overwrites, versioning also protects against accidental deletes. When you delete an object in your version bucket, S3 inserts a delete marker as the latest version and preserves all of the earlier versions. If you didn't intend the delete, you can go back and retain your older versions. Now, you might be thinking that over time, all of these versions are going to sit in your S3 bucket and add to your storage costs. To avoid this, you can use lifecycle transition policies to move all of your older versions to cheaper storage, say Glacier Instant Retrieval or Glacier Flexible Retrieval or even Glacier Deep Archive. Additionally, you can also use lifecycle expiration policies to delete all of these versions after a fixed period of time. Versioning as a feature on S3 is the foundation on which every other data protection feature we're going to be discussing today is built on top of. The next use case I want to talk about is for customers who want write once, read many compliant storage. They're looking for capabilities on S3 to designate buckets or objects to be immutable so that they cannot be altered or deleted by anyone for an extended period of time. In this day and age where cyber attacks are a huge risk to many businesses, a simple way to prevent any kind of deletions or mutations on your business-critical data can be powerful. To solve this problem, let me introduce you to S3 Object Lock. Object locks are a great way to protect your critical objects from getting deleted or overwritten, and you can enable worm type of storage on S3. Object locking can be set up at the object level or the application level or even as a default bucket level setting so that every object in your bucket is automatically locked for your specified duration of time. Object locks provide two ways to manage object retention: a retention period and a legal hold. A retention period specifies a fixed period of time during which your object will remain locked. During this period, your object is worm protected and cannot be overwritten or deleted. A legal hold provides the same protection as a retention period, but it has no expiration date. Instead, it will remain in place until you explicitly remove it. There are two types of object lock modes that I want to talk about today. The first is the compliance mode. In this mode, A protected object version cannot be overwritten or deleted by any user, including the root user in your AWS account. When an object is locked in the compliance mode, its retention mode cannot be changed and its retention period cannot be shortened. The governance mode, in contrast, protects objects from being deleted by most users, but still allows some users with privileges to change these settings. Sometimes we typically see customers who start off with using the governance mode, test out their object locking settings, and then once they are comfortable with the settings, they move over to the compliance mode retention period. Using these two object locking modes combined with the retention period and the legal hold, you can build a scalable worm-protected storage on top of Amazon S3. Now that we've looked at how to protect your data within a bucket, let's now talk about how you can protect your data outside of a bucket or account for compliance. Although Amazon S3 stores your data across multiple geographically distant availability zones by default, compliance might dictate that you store your data at even greater distances, say in different AWS regions. You might also be required by data sovereignty laws to store multiple copies of your data in separate AWS accounts even within the same region. To do this, I'm going to talk about a feature in S3 called replication. We have 4 different product offerings in replication, and you can choose to use them individually or you can mix them up based on your requirements of your workload on Amazon S3. The first is same region replication. Customers who want to maintain multiple copies of the same data in different AWS accounts within the same region can use this for differentiated ownership access or for data sovereignty. The second is cross-region replication, which lets you replicate data into separate AWS regions for compliance. You can also use CRR to minimize latency of your application. Say, for example, you have customers across different parts of the world that are using your application or your business. It might be beneficial for you to replicate your data sets across all of those regions so that your customers can access your business with minimal network latency. Another flavor of replication that helps with compliance is replication time control. If you have requirements on having predictable times for when your data gets replicated, RTC is designed to replicate objects just 15 minutes after upload, with most objects replicating just within seconds. These 3 replication features allow you to replicate newly uploaded objects from a source to a destination. Last month, we launched a new capability to replication with which customers can now replicate already existing objects from a source to a destination. You can also replicate any number of objects in a batch with just a single request. Introducing S3 Batch Replication. Now, there are many reasons why you might want to use batch replication. You can use it for migrations when you need to create a disaster recovery plan. This might require you to copy all of your data in an existing region to a new region, especially for the data that you uploaded before you set up the replication. Next, you can use it to hydrate a secondary bucket in a new region to replicate all of your data from your primary region. Say you're a US-based company and you're opening up a new office in a different part of the world, say Singapore. Now you might want to replicate all of your internal files to the Asia Pacific region so that it's closer to your employees in that office. We also see a lot of our customers who go through mergers and acquisitions who want to transfer ownership from one AWS account to another. Lastly, S3 Batch Replication combines the best of both worlds from S3 Replication and S3 Batch Operations to provide you visibility into many things like active job running time. It provides a completion report after the batch replication completes. It gives you an option to review the batch replication manifest and also has CloudTrail events on the job status. Now, if you're a customer who has tens or even hundreds of AWS accounts or S3 buckets, it might be difficult for you to understand how your data across all of these buckets is protected and managed. With S3 Storage Lens, you can easily understand, analyze, and optimize your storage with more than 29 usage and activity metrics and interactive dashboards. You can aggregate your data for your entire organization at the account level, the region level, the bucket level, or even at the prefix level. Every customer gets a free default dashboard in S3 Lens, and you can see metrics by feature. For example, as you can see here, we have broken down the metrics by percentage of objects encrypted, number of objects that are older versions, how much of your data is projected by locks, and all this allows you to identify discrepancies, and you can drill into for more details. Using all of the tools that we have discussed today, you can now build a protected and compliant storage at scale on top of Amazon S3. You can use our new checksum offerings to verify the integrity of your data you bring onto S3. And once the data is on S3, you can use our features like versioning, object locks, replication, and storage lengths to easily protect petabytes of data on S3. I want to thank all of our customers who trust S3 with your valuable data, fueling our innovation and powering your business on top of AWS. Thank you for watching, and stay tuned for the next session, which is a deep dive on our newest replication feature.
Thank you so much. Thank you so much. I wanted to ask you about this batch replication feature. Now, I was really excited to see that feature launched based on some work that I've done with the customers of AWS. Anusha, can you recap for us a little bit about who is this feature for? This batch replication, when would I use it? You know, because we've had replication in S3 for quite some time. This batch replication is something new. What situations can a customer find themselves in where they would want to make use of this new feature of replication?
Yeah, sure, Becky. As I was mentioning in my slide about the batch replication, I think our existing features on replication before we launched batch replication allowed customers to set up replication and start replicating the objects that they uploaded after that replication was set up. Now, we had a lot of requests from our customers who asked us to provide a capability to replicate objects before they set up replication. Like for some of the use cases I talked about, we have a lot of customers who are now setting up replicated regions for disaster recovery. And they want a simple way to say, hey, replicate all of my objects into this new bucket. And they want to do it for already existing data sets that they've been powering on top of S3. So I think that's really the use case that we want to target with the batch replication, which is being able to replicate pre-existing objects before you set up the replication, and also a simple way for you to replicate petabytes of data with single request, and you can now start tracking the job status on your replication. And this makes it really easy for our customers to set up disaster recovery backups, or when they go through mergers and acquisitions, to easily move data sets across accounts or cross-region.
Yeah, or to put it another way, if you're watching this presentation and learning about our great replication features, and maybe you have some use cases that you didn't have when you first set up the bucket, maybe you're trying to expand your global reach or something like that, you have all this data sitting in the bucket, and you didn't turn on replication at the very beginning, but now you have a use case that needs it. This is basically a way to provide kind of a catch-up replication, a retroactive sort of replication, so that so you can turn on ongoing replication for your new data, but for your existing data, this gets that data replicated as well in sort of a very kind of easy and straightforward and simple setup kind of a way. So if you're seeing these replication features and thinking, gee, I didn't turn that on my bucket, and you want to, this batch replication feature is definitely something that you should be looking at.
Great. So let's go back to those compliance options and get a summary. So, we have object lock, right, which holds the object in place for a set period of time or even forever, okay? We've got the ability to keep around older versions of objects that get updated.
Yep.
Now, these all seem very useful, but as a user, when would I choose one over the other?
Yeah, that's a good question. So object lock and versioning are actually features for different use cases. Now, for businesses who are running on top of Amazon S3, who continuously keep updating their business critical data sets, we really recommend using versioning, because you might want to protect your data against accidental overwrites or even accidental deletes. Now, these are for data sets that are being continuously updated, and you are using them to power your business. On the other hand, object lock is typically used by customers who have data sets that they don't intend to mutate or delete on a regular basis, but have these data sets on S3 for compliance. And they really want to make sure that this data set cannot be touched or deleted by anyone, and sometimes even by the AWS account owner. And for these use cases, you can simply turn on object locking, and the data will not be able to, cannot be mutated or deleted by anybody who has access. Versioning is for data that is frequently touched, but you want to make sure that you're able to preserve all of the older versions so that you can go back and get access to them.
Cool. So we may have some users that are thinking about versions and concerned that it's sitting on too many versions. So I understand there's a lifecycle feature to help with that.
Yes, yeah, as I was mentioning in my slide on this topic, if you have a lot of versions sitting around in your S3 bucket adding to your storage costs, you can do one of two things. Now, if you want to preserve those versions for a long period of time but don't want to pay too much for it, you can use the lifecycle transition rules to move all of your older versions to a cheaper storage class like Glacier Deep Archive, for example. And you can also set a time after which you want to automatically keep transitioning these older versions. Say every 100 days, you want to keep moving your versions to Deep Archive. It'll still be there for you whenever you want to access it, but you'll be paying really cheap cost for it. The other thing that you can do is after even longer period of time, say after a year, once you've confirmed that you no longer need these versions to be on S3, you can set up lifecycle expiration rules, which you can say, hey, delete all of my older versions after a year. They've been around on S3, so you stop paying cost for them altogether.
Great. So Nitish spent a fair amount of time talking about the innovation on the compute object checksums, right? So that's how we know the object that we're holding for the customer is the object that they sent us. From the other side of the fence, as a user of S3 though, are there any indications that I should be looking to use particular checksums instead of the standard durability function that S3 gives us?
Sure, yeah. So S3 is designed for 11 nines of durability. So durability is table stakes for us. So a couple of indications that I can think of would be, first, if you have any pre-calculated checksum already stored on your system for the 4 algorithms that we are supporting, that's a good indication. The other one would be if you need an alternative to MD5 checksums for whatsoever reason. It can be related to compliance or performance improvement. These options are a good alternative for that. Third would be if you're dealing with stream data where you cannot calculate the checksum of the object before uploading the object, then you can use trailing checksums. And I would also like to add one more workflow or use case, that would be if you're trying to check the integrity of large objects, which takes a lot of time. So you can significantly reduce the time it takes to calculate the checksum of large objects by using parallel checksum capability that we have built.
Yeah, I mean, so this is actually what I think, Steve, I think this is a great illustration of just what a wide set of use cases S3 supports. You know, it's probably true for the bulk of users of cloud storage in S3 that you don't actually need these advanced checksum features. S3 is durable, S3 computes checksums, S3 holds onto your data, and S3 returns the data that you want to retrieve when you want to retrieve it, you know, using a variety of storage classes for different sort of cost profiles. But this is a great example of innovation that meets all of these various customers where they are. You know, Nitish just shared with us that there are customers who have already done a checksum on their side with an algorithm that they have. There are customers who are observing that their need to checksum a huge object before they send it into S3 is actually taking a lot of time, and this could be parallelized, which is why the checksum at the end is so helpful, as the graphics in this presentation kind of illustrated for us. So this is really a great example of, you know, S3 serves so many different use cases out there, meeting virtually any type of requirement and any kind of workload out there in the world. And these are the features that meet these different use cases of S3 where they are.
Yeah. I'm curious though, how do we decide which additional algorithms to support?
Yeah, it was simple, talking to our customers. So we talked to our customers, we heard their use cases, and based on that, we decided which algorithms to use or to support. What we did when we were finalizing the design, that we designed it in a way that in future, if we get more customer feedback about a particular checksum algorithm, we can easily support that and add that to our offering.
Why is it so important for customers that, you know, we accelerated that integrity checking of the request by up to 90%?
So customer use checksum validation as a durability best practice. And these improvements will improve performance and reduce the cost to do so. And our goal is to simplify that workflow as much as possible so that our customers can validate objects as frequently as they want and remove all the friction that is stopping them from doing that frequently.
All right, so before we move on to talking about pies, I have one more question for you, and then I'm sure Becky has some more. What are the top data compliance best practices that you would recommend? Oh, sorry. I got ahead of myself there. Go with the flow, Steve. Go with the flow.
Go with the flow.
All right,
We're going to talk about some pie.
We're going to go
here.
talk
All
to the
right.
pie instead.
We're
Yes.
gonna talk
All
about
right.
pie.
So, favorite pies. Nitish, you go first.
Uh,
I shall take a vote.
pumpkin pie?
Pumpkin pie.
Pumpkin pie. Okay, a Thanksgiving fan. All right.
All right. Anush?
Actually, pumpkin's my favorite too.
Wow.
Ooh,
That's
that
unexpected. Pumpkin's getting a few votes here, Steve.
pumpkin has leapt into the lead.
That's surprising to me because I find it too sweet. But, well, thank you so much. Thank you so much, Nitish and Anusha, for sharing with us some of these durability features that that really demonstrate the breadth of use cases out there in S3. Okay, so actually, our next presentation is related to the one that you just saw. We're going to hear a lot more about replication, particularly replication across regions, and what that enables the customers of AWS to be able to do. Okay, now one of the things, as you looked at using the cloud has many benefits for our customers. It has elasticity, it has the ability to do cost optimization, it has this sort of limitless scale that you can't really get in an on-premises environment. But one of the things that you get from the cloud is instant access to global reach. What we mean by that is, increasingly, as a customer of AWS, you're probably building workloads in the cloud to serve a business that itself has a global customer base. Now, global customer base means, often means that you're trying to optimize latency, so that your customers all around the world, the users of your product, the users of your workload, that they're able to get responses they're able to get good performance, good latency out of the workloads that you build, the applications that you build that they're accessing. Now, what you're about to hear here, we're going to talk about building resilient multi-region storage architectures using S3 replication and S3 multi-region access points. You're going to hear from Aditya and Neha about what we've done here. What this really is this is S3's spin on global reach. You're going to see how you can use these replication features and a new-ish feature of S3 called multi-region access points to really simplify this global reach, latency optimization, using features that come right out of the box in S3. Now, of course, we're talking about global reach, we're talking about Pi Day here, Steve, and Pies here. And so this is our supplier for pies here at Pi Day is Baked from the Heart. Baked from the Heart pies in Seattle. Now, of course, that is a single region pie. It's probably the closest AWS, we're here in Seattle, the closest AWS region is our Oregon region, of course. Now, of course, there are many global takes on pie, right? If you construe the term very broadly, there's pies all around the world. There's mince pie. There's pizza pie.
I'll vote for mince pie. Yeah.
There's knishes. There's bao, right? I'm probably not even thinking of the many different takes on pie all around the world. And so it's kind of this idea of this pie construct is kind of a global construct. So I admit that metaphor was maybe a little bit stretched. S3's global reach is a little bit more straightforward, not quite as tortured a metaphor. So I'm going to turn it over to Aditya and Neha, and we're going to hear about multi-region storage architectures in S3.